Problem number 43 is one that gets asked every single year that we assign it, and that's because it's a tough problem. There's a lot of weird stuff going on right here. So let's go ahead and dive in and see where we get. Most people I have found do pretty decent at the beginning of this and then just have a hard time bringing this thing home to match the answer that they have in the solutions manual. So here we go. We've got two different terms here that are being subtracted. So to take dy, it's not going to be dx, it's going to be dy dt. Let's get started. Our first term is an inverse cosine of this t to the negative first power. So derivative of inverse cosine of something is going to have a negative 1 up on top over then the square root of 1 minus u squared. And our u is going to be this goofy thing right here, t to the negative first power. So we've got to square that, and so just real quick, that would be power of a power. That's when we multiply our two exponents together right here. So that is going to become a t to the negative second power, but not done yet, guys, times the derivative of u. And the derivative of that t to the negative first is going to be a negative 1 times t to the negative second power. That's a step that a lot of people forget in this problem. So there's a lot of simplification here that we're going to need to do, but we'll save that for the next step. Minus, let's move on to the second term now, and this one's actually much simpler. The derivative of inverse secant of t is going to be a positive 1 up on top, multiplied now by the absolute value of u, which for us here is just t, times the square root of u squared minus 1. So that's a t squared minus 1 right there. And that step, everybody, is the completion of the derivative. That's the calculus. Everything else is algebraic manipulation from here. So let's see where we can get to on the next step. For starters, if we take a look at that numerator, we've got a negative 1 times a negative 1, which is just positive 1. And then we have a t to the negative second. Nobody likes that. So I'm going to move that t to the negative second down to the bottom where it's going to become t to the positive second. And I guess at that point, I'll go ahead and put that positive 1 in the numerator. Now that now is going to get multiplied by the square root of, and take a look at what I'm going to do here. I'm going to change that 1 into a t squared over t squared. And the reason why is probably going to become apparent in just a second. Minus t to the negative second, we're going to write as 1 over t squared. And maybe now you see it. I wanted a common denominator there so that I can put these two fractions together in hopes of working towards simplifying that denominator. Okay, minus. Now this second term is going to start to get pretty bored right here because there's really nothing we can do to clean this up. So that's going to stay just the way it was. And there you go. That guy's just kind of hanging along for the ride until that first fraction makes some progress right there. So where are we now, guys? This is going to be a 1 over, and where are we here? I'm going to keep that t squared in the denominator. And now, in the radicand, we're going to put those two fractions together because they have that common denominator. And what I'm going to notice here, guys, is that the denominator down there, which is going to be t squared, is a perfect square. That means that it's probably advantageous to go ahead and make this the square root of the numerator. So that's the square root of t squared minus 1 all over the square root of the denominator. And the square root of t squared is just t. And maybe now you're seeing what's about to happen in that denominator of the first fraction. Now again, this second term is getting bored here, just tagging along for the ride. Okay, and here we go. Let's see what's happening next. Let me shrink this down a little bit here, you guys. All right, and let's see where we can go from here. Now, if we focus just in the denominator of that first fraction, this t squared out here is getting divided really by this t, so one of those t's is going to cancel out, leaving us with a 1 over. It's basically t squared divided by t, so it's just 1t now, times the square root of t squared minus 1, minus 1 over the absolute value of t times the square root of t squared minus 1. And we're so close now to having a common denominator between these two fractions. It's going to be very tempting to say, let's put them together, but a lot of you guys are probably hesitant to do so because of the absolute value that you see right here that you don't see right here. And probably good on you if you looked at that and said, wait a minute, they're not quite the same. I can't really put them together. But if you think about how we got this t, something really nice happens here. Let's take a look. That t came by taking t squared divided by this t right here. And that t in the denominator came from right over here, you guys. It was the square root of t squared. Now, taking the square root of t squared guaranteed that this t was going to be positive. Squaring this number right here guaranteed that it was going to be positive. And a positive divided by a positive guarantees that this t is going to be positive. And if that t is known to be positive, what we're really doing is taking the absolute value of that. We know that this result will be positive. This result then is going to be positive as well. There's the common denominator that we were looking for. And if you notice, this is kind of the big payoff to this problem. These two terms end up identical. And if you're subtracting them, we end up with a nice big fat 0 here for our final answer. So that's how you come up with that answer there in problem number, forgot what it was, in number 43. What that probably tells us, you guys, if the derivative ended up being 0, it probably tells you that the original expression up above could probably have been rewritten into some particular constant value, because the derivative of a constant is always equal to 0, and that's the only type of function where that works out. But that involves some weird trig that we're not going to get into right now. I'm sure it would work out, but we're going to leave it at this. So that's a tough one, guys, but that's how you do 43. That's definitely in the realm of question there that I wouldn't expect you guys to get on your own the first time through. Don't feel bad at all if you needed some help on that. But hopefully once we've gone through it, it made some sense in terms of the simplification steps that we did, and you can understand where that answer came from. So if a problem like this ever shows up again, hopefully we'll be a little better equipped to handle it in the future.